Hi everyone, hello, welcome to the stream. Hi, hello Tasif Pro Gamer, hello, hi. So for this question, for which operations does the closure property for integers does not hold? Hi Tasif Pro Gamer. So now we know that subtraction. Hi, hello everyone, hello. We have 21 people. Wow. Hi everyone, hello Braden's Exploring in Trains. Alright, so the first question is, for which operation does closure property for integers does not hold? We know the closure property means whenever we add, multiply, or subtract any two rational numbers, we get a rational number. But when we look at for division, it doesn't, the property is not applied. The property does not apply. The property does not apply to division. So the answer is division. The second question. For two integers p and q, p by q is a rational number, then write the condition for q, p by q to be a rational number. So whenever we have a rational number, the number in the denominator should not be 0. If it is 0, then the number is not defined. So that is the reason whenever it is a rational number, we should not have 2 as a denominator. So we should not have 0 as a denominator. So that's the condition for q. Now, the next question. Name the property of addition used in the x following expression. 5 plus minus 5 plus 7 is 5 plus minus 5 plus 7 is equals to 5 plus minus 5 plus 7. Yeah, it's the associative property. The answer is it's the associative property because we know in associative property, if we have three rational numbers, a, b, and c, then a plus b plus c is equal to a plus b plus c. Now, give an example to show that subtraction is not associative for rational numbers. We already know that subtraction is not commutative for rational numbers. So, if it's not commutative, then how the hell is it supposed to be associative? Because, commutative and associative are related to each other. Are pretty much almost related. They're literally almost the same. Almost the same, not completely same. Because the associative has an extra number in it. That's the only difference. Otherwise, it's completely same. So yeah, if it's not commutative, then it's also not associative. Simple. Now, rational numbers are commutative under addition, but not commutative under subtraction. Like let's say we have two rational numbers, 5 plus 3. So 5 plus 3 is equal to 3 plus 5 because 5 plus 3 is 8 and 3 plus 5. So 5 plus 3 is equal to 8 and 3 plus 5 is also equal to 8. If we imagine this as apples, we have 5 at the beginning and we add 3 to it and we count 1, 2, 3, 4, 5, 6, 7, 8. See, now if we imagine this again, then we have 3 at first, so 3, and we add 5 and 1, 2, 3, 4, 5. So you see, you get the same number, so this is commutative. Now, if we are doing subtraction, like 5 minus 3 is equal to 2, 3 minus 5 is equal to minus 2. This is because, let me show you. So you have 5 apples, then you remove 3, you have 2. Now if you have 3 apples, and then you remove 5, you remove these 3, so you get 0. But there's one imaginary apple, which is actually in the mirror world and is never to be seen. So, of course, there's no idea. This ideology doesn't work. No, this ideology of the mirror world doesn't work. But if you see this is what it is. So that is why subtraction is not commutative. So, next question. Now, simplify 4 by 5 plus 9 by 2 plus minus 4 by 5. So, 4 by 5 plus 9 by 2 plus minus 4 by 5. We notice that these two are additive inverses of each other, so they're 0 and they get cancelled out. Now, 9, but this is 9. 9 by 2 is the only number which remains, and it is the answer. Or specifically, the answer is 4.5 to be precise. Now write the multiplicative inverse of 312. Alright, so yeah. So, the multiplicative inverse of any number a is actually 1 by a. So let's say 312, the additive inverse, multiplicative inverse is going to be 301 by 312. Find the multiplicative inverse of minus 1 by 13. The answer is minus 13 by 11. Give the reason why multiplicative inverse of 0 does not exist. So see, when you have, so let's say we write 0 by 1, this is actually 0 again. So now if you flip this, you still get the multiplicative inverse, but however, you multiply them, you get 1 as well. But this can be a constant. This cannot be a constant. Because this thing is not defined. See here? 1 by 0 is not defined. So that's the reason it does not exist. Otherwise, you could have used it for monogen to do it. Now, we have write the multiplicator and the additive identity of rational numbers. So the multiplicative identity or the MI or Mumbai Indians is 1, while the additive identity or artificial intelligence is 0. Last question, find the value of 0 divided by 5 by 4. So 0 divided by 5 by 4 is just going to be 0. No, that's it. Just kidding, that's not for the video. Now, so we are done with the very short answer to questions, as I promised. But now, you guys want some more, so let's do some objective questions. The multiplicative inverse of 1.6 is 5 by 8. Yeah, that's true, that's correct. Multiplicative number. So yay is true and R is false because the multiplicative inverse is just flipping the number upside down, but it's not giving the number a negative sign, not like additive inverse. The next question: for any three rational numbers x, y, and z, me and both are correct. I mean both are correct, yeah. If x is 0 equals to 0 plus x equals to x, x is a rational number, then 0 is called x. What the? 0 is the additive inverse of x? So R is true, but A is false, so the option is D. Let me... What? Okay, we're done with assertion and reasoning. Now we gotta move to the shop. Fill in the blanks. Multiplication and addition of two rational numbers hold the stipulated property always. Multiplication or addition of two rational numbers is always a rational number. Now, the 1 by 527 plus 1 by 127 plus by 31 plus 1 by 532 by 37. Alright, then we have multiplicative inverse of minus 15 by 17 is minus 17 by 15. Multiplication of rational numbers is distributive over addition and subtraction both. Now let's whether true or false. If a by b is a rational number, then b can be any small number. No, that's false. 0 is the smallest rational number. There is nothing called the smallest rational number. There are infinite number of smallest rational numbers, but the smallest natural number is is the whole number. So 0 is the smallest rational number. That's false again. Rational numbers are closed under addition. We should say that's division. No, that's false. Because I can't say that it's always closed under division. Sometimes we can. No, wait, it is closed under division. If p is equal to 0, then the multiplication of p by q is q by p. Yeah, that's true. Next, for every rational number x, y, and z, x, and x, yeah, that's true. Let's do match the following and we'll end the video. Anything in identity of 4 by 5 is 0. As an answer minus 3 by 9, minus 3 by 9. Multiplicative identity of 3 by 8 is 1. Multiplicative inverse of minus 1 by 5 is minus 5 by 6. Now the next one. Additive inverse of 0 is not defined, and the natural numbers are not associative for division. The reciprocal of 0 is 0. Sum of additive, no, wait. Yeah. Reciprocal of 0 is not defined, sorry. Additive 0 is 0. The 0 for 0 is not defined. The sum of additive inverse and the multiplicative inverse of 3. What? So minus 3 plus 1 by 3. So minus 9 by 3 minus 8 by 3. It's 2. So that's all. We completed the Arihant book. We have just long answers to complete. So thank you guys for watching, and I'll see you next time on the next video. Please like, share, and subscribe. Bye. 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 Bye.